Hi, everyone. Hope you're all continuing to stay safe and healthy. It gives me immense pleasure to welcome you all to today's webinar. The CEO and founder of Pixida and an industry artificial intelligence expert, Nisha Talagala, will take you through the hottest, much in demand, and upcoming data science career space. She'll talk about what roles are available in this space and how you can launch yourself into a career in data science. Couple of points to note before we begin. During the webinar, Nisha will take 1 to 2 questions after every few slides, and we will open the floor to a Q&A session in the end. We plan to have at least 15 minutes to give you enough time to ask your questions. Now, in the event your questions don't get answered, we will circulate a mail to all of you and give you a chance to answer them. Now, this mail will also include information on her organization, Pixida, and its training programs, and a copy of today's presentation. Now, during the webinar, as and when you have any questions, please feel free to post them on the Q&A window. Before we begin, let's get to know Nisha and the organization she founded, Pixida AI. Nisha, if we can have the next slide, please. Nisha is an entrepreneur and technologist in the artificial intelligence space. A recognized leader in the operational machine learning space, Nisha has more than 20 years of expertise in software development, distributed systems, technical strategy, and product leadership. She earned her PhD at UC Berkeley and holds 71 patents in distributed systems and software. Nisha is a frequent speaker at industry and academic events and is a contributing writer to Forbes Online, Cognitive World, and other publications. Now, the organization that she founded, Pixida AI, the mission for the organization is to enable people from all backgrounds to learn, practice, and apply artificial intelligence. Nisha, thanks for hosting this exciting and super relevant topic for our returners today. It will be helpful for our audience to know how they can transfer skills picked up in their previous careers and make a possible pivot to a career in data science. Also, I'm curious and would love to know why you decided to name your organization Pixida and what it means. Please elaborate on that for our audience. Thanks.
Sure.
Over to you, Nisha. Yeah.
Thank you so much. Pixida is actually a variant of a Greek word called pixis, which means compass. And so we chose Pixida because, it's intended to provide a sense of direction. And you can also see that our logo is actually a little compass. And we provide, some software that we call navigators. It's all about really helping people find direction.
Thanks for the.
Should I get started, guys? Yes. Yes. So everyone, welcome. It's really a great joy to talk to you guys today. Let me go over kind of what we are going to cover today. So the agenda for the webinar is, first of all, why a career in data science? Why should you consider that? What is this field and why is it exploding? Then I'll talk to you guys a little bit about what roles exist and what you need to know about these roles, and then how can you get started and what's involved in getting into this field. And then we will just jump into some Q&A, and we'll probably do some Q&A in the middle as well. So Deepika, whenever we want to do the Q&A breaks, please just let me know and we can take a pause and then Q&A. Yeah. So let's go ahead and get going. So first of all, before we even jump into data science, I just wanted to give you guys a bit of a feel for what this field of artificial intelligence is all about. Chances are, whether you've really thought about it or not, you've used some form of artificial intelligence, probably even this morning in your daily life. Because artificial intelligence is fundamentally the way that, computer programs do things that come very naturally to the human brain. So things like recognizing sounds, images, predicting the future, strategizing, figuring out, planning things, figuring out what to do, in what order, noticing when something is unusual, playing games, trying to win. All of these things are things that come very naturally to the human brain, and artificial intelligence is fundamentally about helping computers and computer programs perform these tasks. Now, so that sounds good and abstract, but then why is that useful? Well, so it has many, many practical usages in real life, and here are, for example, some of them. So self-driving cars are clearly, one of the most kind of fascinating things that has come out of artificial intelligence lately. And this is a really simple picture of how a self-driving car sees the road in front of it. So typically there's one or more cameras in the car, and then they take pictures all the time. And then what you're seeing here is essentially an object detection system where it has figured out that there's at least 6 different moving vehicles right in front of it. And then it gets a sense of how fast are they moving, and from there it can tell whether it's likely to run into it or not. Digital assistants abound, in homes. You can speak to them, get information, things like that. This is actually a picture I took from the TED Talk of the first picture ever taken by humans of a black hole at the center of our galaxy. And, forms of algorithms were used to actually reconstruct the picture because we are not yet technologically capable of taking a direct picture. There's also other, tasks like, detecting emotions in people, used for customer service, predicting the weather, simply identifying what's in an image, things like that. And so those core techniques of artificial intelligence are used in a lot of these kinds of applications that are typically permeating these days in any aspect of daily life. Now, even underneath some of these, more, advanced looking forms of artificial intelligence, there's also a lot of really just bread and butter business problems that solve problems for companies and help companies make money at the end of the day. And this is what powers the need for AI and for AI engineers. So let me take you through kind of what a cycle of a problem solving inside a business. Like a business could be something like a bank, a big healthcare company, a supply chain, things like electric, like for example, electricity providers, things like that. And so typically you start with a business need. So simple business need might be something like, I want to, recommend products to my customers. If a customer bought a product, I want to know what second product I should recommend. So that's my problem, and that's what I want to solve. Then then I have to gather data and say, okay, what do I know about my customers? What do I know about their purchase history? And from that data, can I figure out if they bought, for example, balloons and birthday candles, maybe they want a birthday party banner, something like that. Once I have some data, then I pick a type of AI, which is typically called a model or an algorithm, and I train it to try to recognize the pattern in the data. Once I'm convinced that I've trained it, then I test it with some information that I know to try to see whether or not it's capable of making good predictions. If I'm convinced that it is capable of making good predictions, then I do what is called deploying it. And deploying it means I connect it to, for example, my shopping site. So then I'm connected to my shopping site. And now, next time a customer comes over to my shopping site and buys, let's say, pasta, then my AI is probably going to look at that and say, okay, I'm going to recommend pasta sauce, something like that. Now, how do we know if this AI is actually helping the company? It's helping the company if the customer buys the recommended product. If the customer does not buy the recommended product, then I'm not making any more money. And chances are my prediction was wrong for some reason. It did not clearly assess what the customer wanted. So this is what I mean by monitor and optimize and see if it is meeting the need of the business. Sometimes it meets it, sometimes it doesn't, sometimes it can be made better. So then you go around the cycle again and try to figure out whether I can make it better. And over time, I come up with a bunch of different improvements. And over time, my business starts making money from this artificial intelligence solution. So this is the life cycle that, even though it sounds very simple, is the life cycle that is followed by a large variety of businesses. And this life cycle is not delivered by a single person. It's typically delivered by a relatively large team. And that team contains people with lots of different roles. For example, there could be application developers who make sure that the website looks good and is properly connected to the AI. There are data scientists who try to figure out this part of the life cycle. What is the best way to learn from the data? There are machine learning engineers who figure out what is the best way to deploy this AI that I've built and connect it to my business app. And then there are operations people who just make sure that the whole thing keeps working and doesn't crash and doesn't, deliver bad results or have bugs or things like that. So the first thing to kind of recognize is that, AI is very prevalent now because of all these different things that it can do. And, businesses need AI because there are ways to use the AI to essentially improve the quality of things they already do and likely make more money from things that they already do. So they deploy these AIs in a life cycle like this. And to deploy those AIs, they typically need a small army of people in different roles. And so this is where the jobs are coming from. The jobs are coming from the fact that companies want to do this life cycle, not just for one of their products, but typically for hundreds of different products. And so every time they want to do one of these, they need a small team to put some amount of time into delivering that and taking care of it and making sure that it is adding value and continues to stay healthy. So that is the basic reason why data science as a career is starting to come about. So now what we can do is we can basically now go from this overall need to what do the careers actually look like. So first of all, just to kind of make sure that there's sort of some clarity, so far we have been talking about artificial intelligence. So why is it that the careers are called data science and the area is called artificial intelligence? So artificial intelligence tends to be kind of like the marketing or kind of, public term for these types of techniques. What happens, in the details is usually some kind of science or some kind of engineering. So you will very rarely find a job that says, I'm looking for an AI person, or a job that says, I'm looking for an AI engineer. Typically, the jobs will say, I'm looking for either a data scientist, or I'm looking for like a machine learning engineer or something like that. And so the way to think about it is AI is like the marketing, public, sort of like press release kind of term. Data science is what actually happens behind the scenes to make the AI work. So the two things are basically one and the same. It's just that they're not always used in the same way. So once you kind of figure that out, data science is one of the fastest growing technical careers out there. So there are many studies right now about the artificial intelligence market. This is simply one of them. It's growing at an annual, compound growth rate of 55% or so, and it's basically expected to grow, at these massive rates for the next, 5 to 10 years. Now, most of the studies, if not all of the studies that describe the growth rate of artificial intelligence, say that one of the main reasons why this may not be achievable is because there just aren't enough people to basically make it happen. So this is the way that businesses would like the AI space to grow. It reflects the kind of things they want to do, the amount of money they think they can make. But in order to make this and make this growth a reality, they are going to need a lot more people than they currently have. So all in industries are seeing this gap of skill, which is the reason why this career is booming. This is actually a quote from IBM that I really like. It basically says that they expect 120 million workers who are existing already in the workforce will need to upskill to learn about AI in the next 3 years in order to keep these companies competitive. So a few things that you need to kind of realize. So the first is there's a ton of new people entering this field right now. So also the field itself is not that old, so I've been working in the AI field for a number of years. And, one of the things that, a few years ago when I was hiring, when a recruiter asked me, do you want someone with 10 years of experience? And I basically had to tell them there is no one on the planet with 10 years of experience in what I'm looking for. It hasn't existed for 10 years. So the basic thing you kind of have to realize is that even if it seems overwhelming, it just hasn't been around long enough. So there are people who have decades of experience in artificial intelligence, but they're not your everyday worker. They're usually professors in universities and stuff like that who've been doing research for a long time. The average data science person really just has not been there long enough because this job has not existed long enough. So don't feel intimidated. You're not behind. It's a very, very young field, and you basically have as good a chance as anybody else at learning it. Now, there are a fairly wide variety of roles, and I'm going to spend some time today talking about 2 of the roles to help you understand sort of what's involved. But I made a list of a bunch of roles here, and there are a bunch of them. So there's a role called a data scientist. There's another one called a decision scientist, which is slightly different from a data scientist. There's one called a business analyst, a machine learning engineer, a machine learning operations engineer, and more of an Uber kind of umbrella, jack of all trades kind of role, which is a full stack data scientist. So the first thing to kind of think about is, many roles have entry level functions, which is where you should really target. But the way to probably think about these different roles is that they mostly vary in how much business oriented you are and how much technical oriented you are. So for example, the business analyst is much, much more business oriented than they are technical oriented. And a pure data scientist is usually more technical oriented. So you can kind of take an entry level role in any of these areas, and you can then over time kind of determine where your personal interests lie, and then you can navigate your way across these ranges. So a lot of business analysts, for example, take data science, move more into the data scientist realm. And then there are some data scientists who want to learn more about the business. Like for example, if they're in healthcare, there are laws involving healthcare that they might want to get to know better. And then they might, migrate or expand their skill set to include more business analysis. So the types of roles are ever expanding. And part of the reason they're expanding is because of this, because the market in general is also expanding like crazy. So these are a bunch of different roles. And what we will talk about today is essentially, two of these roles. We will talk about an entry-level role in data science and an entry-level role as a machine learning engineer. And I'll help you guys try to understand sort of what is involved in each one of these roles.
That's a fantastic explanation of the roles that are available in this space. Nisha, we do have one question. Would you like to take it right now, or and it is pertaining on the roles. So one of the audience members wants to know what types of roles in analytics data science exist that are suitable for people who don't want to do a lot of programming.
Yes. So the question I think is, what are the roles for people who don't want to do a lot of programming? So the business analyst role and the decision scientist role tend to be for people who don't want to do a lot of programming. These people typically use software that you don't have to write code for. Usually the software itself can do different kinds of analytics for you. And you typically, what you bring to the table, your value is is your understanding of the business and your ability to use the software. So an example of a really powerful piece of software for this is Tableau. So Tableau doesn't require you to be programming. It just requires that you know how to use Tableau. Excel spreadsheets are definitely the go-to way to do initial analytics. So there's lots of things like that. They tend to fall into the decision business analyst role and things like that. So I see other questions as well. Do you want to just feed me the questions that you'd like me to answer right now?
Yeah, we can take one more question at this point. So another question that we've got is, what is the difference between data analytics and data science? Where does data analytics fit in the realm of artificial intelligence?
It's actually an extremely good question. So you can think of data analytics. So part of it is that sometimes these terms are also evolving and they tend to be a little bit vague intentionally. But to a first order, data analytics is really about analyzing the data in probably more explicit ways. And data science tends to be more about making predictions or what's called finding insights that are not usually found directly from analytics. So I'll give you an example. If you are doing trend sheets, like supposing you need to give your boss a report saying how has sales been for the last 4 quarters, and you need to break down, here's the overall sales, here's the sales by by business unit, here's the sales by product line, how much has sales increased between the last quarter and this quarter. That is not data science. That is straight up data analytics. It just simply means you've got a lot of data, you're going to crunch the data, and you're going to prepare reports. And that kind of stuff is incredibly valuable and does not go away. If you are going to the state that you're saying, you know what, based on this, I am going to make a prediction about how much my sales are going to be 3 quarters from now. Or I'm going to look at customer satisfaction reports by analyzing emails that our customers have been sending to our support email alias. I look at those, I do some analysis and try to tell whether the customer is happy or dissatisfied, and I try to figure out if that's correlated to my sales, that's data science. So typically analytics is where you start. If you haven't done some analytics, it's usually not a good idea to do data science. But data science follows analytics.
Understood. Thank you for that explanation, Nisha.
Do you want me to take any more questions right now?
I think we can proceed with the rest of the presentation and then take a few questions.
Sounds good.
Indeed.
Okay. So now that we've talked a bit about these data science as a career, let's talk a bit about actual careers. So let's talk about some of the roles. So one of the roles is that of a classic data scientist. And by the way, when I describe these, I'm thinking about them in the entry-level way. So this is more of the junior kind of data scientist. And then you can kind of grow from there. So what do they do on a daily basis? Like if you're a data scientist and you go to work in the morning, what are you going to do? Typically what you'll find is that you have been given a problem, and the problem is going to sound something like, I would like to predict how much sales I'm going to have in the next quarter. I would like to predict, which of the features of my product, say that I wanted to add 3 features to my product. I'd like to know which one is likely to generate the most revenue based on historical information about how customers use my product. So they get posed a problem like this. And then usually the first thing that they do is they go looking for data. So they will basically look at, okay, what data do I have? What database does it live in? Then I'll probably bring my data into something like an Excel spreadsheet or something like a notebook where I can crunch on the data in a programming language like Python. And then I try to play with the data to see what it tells me. Once I have a sense of what the data is, then I'm going to pick an artificial intelligence or machine learning model to try to predict what I want to predict. Then I'm going to try to figure out whether the model is working well. If I come across a model that's working well, then I'm going to present that model to the rest of my team and say, okay, here's the data that we have. Here's what I did. Looks like it predicts pretty well. So if my question was, for example, something like, I want to predict the effectiveness of a future feature, okay? Then what I could do is I could run an experiment that says, if a year ago I had predicted the effectiveness of a feature I have right now, how effective would my AI have been? So I can say my AI has been effective, in which case now I feel more confident that it can predict the future as well. So typically this is what they do in daily life. They look at a problem that's given to them by their company. They search their company for data that is relevant to this problem. They make the decision of which data matters. Then they churn on the data, they look at it, they might change it, they might decide to sort of like divide columns by their averages to get better effect. They might throw out some data that they think is not relevant. Then they try out a bunch of models, find something that works, and that is their contribution to their team. So if you go back to this, life cycle that we had here, they handle this section of the life cycle. So they are given the problem, they handle this bucket, this bucket, this bucket, this bucket, and this bucket usually. And their contribution is that they find a satisfactory outcome here and give it to whoever's running this bucket. So that is what data scientists typically do on a daily basis. All industries are hiring, and for pretty much every kind of problem. Career growth looks like you can become, over time, you can become an expert in your company's domain. You become typically the person who knows the data really well. Typically data scientists go from being entry level to becoming senior data scientists. Some choose to go into management and become the sort of the manager of their team. Some choose to learn more about the other aspects of the life cycle and become more broad and full stack kind of oriented. So full stack is the term for people who know all the aspects of the life cycle. Now that's not something you should aspire to at the beginning, because that's a fairly hard thing to do. So don't think about it as something you have to do at the beginning. Nobody expects you to become that at the beginning. But if you start as a data scientist, it's certainly somewhere you could go in your future. So that's one role. That is the data scientist role. Now there's a related but different role, which is called the machine learning engineer. Now, what is the difference? So the machine learning engineer typically is not the one who creates the AI model. So the data scientist is the one who finds the problem, tries out a bunch of models, finds one model they like, maybe 2 or 3, and then they decide which one is better, which one is backup. They give that to the machine learning engineer. So the machine learning engineer is given a model. Usually it could be something that's sitting on a laptop, for example. And then they try to figure out how to actually make this model work in the company's real system. For example, if I'm talking about a recommendation for new products, obviously the company's website is not going to go to the data scientist's laptop to try to find a product recommendation. The model that the data scientist created in their laptop has to be put into the company's mainline infrastructure, which may be running in their data center, it may be running in the cloud, wherever. And the machine learning engineer is the guy who needs to do that, or the guy or the gal who needs to do that. So their job really is to take these models from the data scientist, figure out what it takes to insert it into the company's running system. Sometimes that means that it has to be retrained on a much larger data set. Sometimes it means that it has to be rewritten to make sure that it can run at scale. So having your laptop, answer one query at a time is entirely different from your data center having to handle 10,000 queries a second, because that might be actually what your website needs. And so sometimes you have to take the model that the data scientist gave you and say, okay, if I have to have 10,000 queries answered by this model every second, how do I have to rebuild it so that it still remains what the data scientist wanted, but is now running much faster, much more in parallel, stuff like that. And their job is to basically get it working inside the system. So now if you look at the life cycle, they typically enter somewhere about here. They should have some understanding of the model, but they don't necessarily have to understand the process that resulted in it. Their job is to carry it through this way and keep an eye on it while it's happening over here. So data scientist tends to be their majority time is spent here. They may be aware of what's going on here. The machine learning engineer, majority of the time is spent here. They're probably aware of what's going on over here. So that's a learning engineer, and they are also needed in all sorts of industries. What is the next step? Can certainly get more data science expertise. If they want to go more into the algorithms, they can become what's called an AI infrastructure architect, which is basically that they understand the systems really well, and they stay more on the operational production side, making sure things work, making sure things are built at scale, stuff like that. And they certainly can go into management for a team of engineers of their kind. So those are two different roles. And both of these, by the way, are in extremely high demand. The kind of compensation you can get for these varies obviously by geography, but they tend to be very reasonable compensation and tend to be more on the high range for entry-level computer science jobs. So what kind of skills are typically needed in order to pull off one of these careers? So a couple of different things. The first thing is really that you want to be able to think logically, because a large fraction of being successful in the data science field is really understanding the problem. So the customer's problem and understanding it and how to map a topic to it is usually far more important than trying to use the most advanced algorithm out there. And this, by the way, is a very common misconception in data science, which which sometimes makes it hard for candidates to find jobs and sometimes makes it hard for companies to find candidates. Is the main thing to remember is that from a company's point of view, they are not looking to use the most advanced artificial intelligence that they read in the news. They are absolutely not interested in that. They are interested in making money in the safest, most effective, most practical way possible. So one of the biggest, it's kind of like it's a sad kind of running commentary among employers of data scientists, is that there's many of them have this sad scenario where they had to fire a PhD. And they talk about it because it's so unfortunate. And it goes something like this. Basically says, I hired a data science PhD. It took me months to convince this PhD to join my company. They were so in demand. And finally, I convinced them and I paid them more than I could afford to pay them. And then I found that they didn't understand my problem. They wanted to use the most advanced research they knew about, and they simply wanted to, try to figure out a much more advanced algorithm every time. And then I waited for months. This person fought with all my engineers. I couldn't get them to deliver a solution to my problem. And I had to, at the end of the day, I had no choice but to fire them. And so this is an important disconnect, because part of what happens in AI frequently is there's so much hype out there. And the hype is that there are so many fancy techniques. Every day you find, a yet more fancy technique. Most of the AI that gets deployed in real businesses tends to be rock solid, bread and butter, kind of what I would consider to be like the Honda Civic of what a Honda Civic is to a car is what you want in AI. Nobody wants to deploy the Ferrari. The Ferrari is dangerous, it breaks. What you want is people who understand how to build the rock solid, powerful algorithms, but are also open to understanding the customer's problem, understanding that the business needs an answer, and being able to work well with the team. So this is really important, and this will come down to what I'm going to talk about in the next few slides. So you need to be able to think logically. Programming is a requirement in most of the jobs. It's a different level of requirement for different jobs. Like I mentioned, the data science, the decision analyst and the business analyst have very little programming. The machine learning engineer has a lot of programming, but in general, knowing some programming absolutely is helpful. So even if you're a decision scientist or a business analyst, I would strongly encourage you to learn a little bit of programming. You need some experience with at least several algorithms. You need to know how to use them. You need experience with at least one kind of data science tool. Typically 2 or 3 would be nice, but usually what happens is if you learn one, it's very easy to learn another. So generally, knowing a few is helpful. And then if you're more on the production side, you need to know how to build something called a pipeline. And a pipeline is basically data comes in, data gets processed, AI gets trained, AI predicts. So that's a pipeline. And you need to get used to the idea of building one of those. So now a bit of what do I generally look for when I hire data scientists? And this is, by the way, a little framework that I developed about 5 years ago when I started, needed to hire a team of machine learning, my machine learning team. And I actually wrote an article about it. This isn't, you can Google for this article. It's called Hiring a Data Scientist, the Good, the Bad, and the Ugly. And it's, it's an article I wrote for Forbes on my experiences, right, hiring data scientists. Generally speaking, the way I tend to do it is I have these 4 things that I'd like to know. Does the candidate know some types of AI? Have they, do they know a few of them? They don't have to know everything because there are hundreds of different types of AIs out there. Do they know a few? Have they used these to solve a real problem? This is very important because if you know 20 in theory and you've never applied one, that's nowhere near as valuable as you know 3 and you've applied 2 of them. Then, do the algorithms work inside? Do they know anything about the math that's behind them? And then have they built any of them from scratch? Now, the key thing to recognize here is that most people on the planet cannot do all 4 of these things. And so what I generally looked for is that in an entry-level role, I'm looking for somebody who knows 1 or 2 of these 4 things. In a more of an intermediate to senior role, I'm looking for people who know 2 or 3 of these things. And then depending on what I need, I might decide that I'm satisfied with people who know 1, because you can actually get a lot of good work done. For example, if you know these 2 things, you can become extremely valuable to a company. A senior person who might be required to lead other people probably needs a 3. And people who know 4 or more tend to be, what are called unicorns, which is they're very hard to find. And frequently you just don't need that level of expertise. Now, beyond these kinds of skills, one thing you should always try to, recognize is that will they work well in a team? Because, as you've seen, kind of to deliver the data science life cycle requires a team of people. And ultimately, the life cycle does not get delivered well if this person cannot work with their team members, and if this person doesn't appreciate what the business needs. So this is very important. And this, by the way, is something that you don't need technical skills to show that you're good at this. If you're a good team player, you've done good teamwork in other fields, you can listen, you can understand what people want, you can understand what your company's problem your company is trying to solve. I find that in general, I tend to, be more favorable to people who know something here, but are good here because I know this stuff can be taught. What I find in general is that if you're not good in this, it's very hard to teach it. So I've frequently hired junior candidates who I felt had one or two of these, sometimes even one, but I knew that they were okay here. And I knew that given enough time, I could teach them these things. So that's something to think about, is that that is what really you need. And this is something, by the way, in your own resumes and your own life, you probably want to highlight. You definitely want to capture one or two of these, because it's going to be hard for a person who has zero in this field to get hired. But don't forget that you're good at these things also. Now a little bit of roles and skills. This is obviously intentionally a little bit vague, but I wanted to give you a feel for where the balances lie between the data science, the data scientist and the machine learning engineer. So first, the areas, okay? Knowing algorithms and data science tools and data science packages is blue, math is yellow, programming is purple, and production tools like production pipelines, like cloud tools for deploying AIs, connecting AIs to applications is green. A data scientist is heavy on the algorithms and tools. They tend to be a little heavier, or quite a bit heavier on the math background. They need to know some programming, but definitely not much or any production. A machine learning engineer, much less on the math, quite a bit, much less on the algorithms and tools, much heavier on the programming, and much heavier on the production side. So there's also a Forbes article that I wrote on this topic, which is called The Full Stack Data Scientist, that you can read, which basically talks about these 4 roles and how you can deal with people who have different mixes of them. So one way to kind of think about it is that if you are really more into the algorithms and you really you wouldn't consider yourself an engineer, then probably the data scientist role is for you. If you really feel like you're more of an engineer at heart, you like programming, you enjoy being around programs, and you're not really feeling like, I want to really understand the algorithms, I mostly just want to see them work and solve problems, then probably the ML engineer is more right for you. So that's kind of gives you a feel for what these roles look like. And I wanted to give you a feel for what a training program looks like. So here's a sample program. We have programs like this, but the basic idea here is that it's a 3-month program. It teaches you enough that you can get started in either of these roles, and you can take a specialist function as a specialist training after that, which will then help you to kind of double down on the role that you like. And what it covers typically are things like you learn on production tools, like Amazon Web Services has a series of production tools that can be, by the way, facilitate this blue block. Sorry, this is not working. Facilitate the blue block and the green block at the same time. You can learn, and focus heavily on the blue segment of how do you build and train AIs, and a little bit on the green segment on how you deploy them. We build a bunch of production AIs with public data sets. So one thing, by the way, is that there's a massive array of really, really high quality public data sets out there. So you can experiment, you can demonstrate your AI prowess using a ton of public data that's also extremely sophisticated, and you can definitely learn how to handle real world data sets by using public data sets. So there's a website, for example, called Kaggle, which has thousands of public data sets out there. And if you haven't tried it already, I would strongly encourage you to go look at Kaggle and look at some of the data sets and look at what people have done with them, because it's a really wonderful tool for people who want to learn data science. There are also public data available from places like the Centers for Disease Control, the World Health Organization, environmental groups, things like that. And particularly if you're interested in timely topics, there are now massive arrays of data sets made public about COVID-19 from so many different sources out there. So it's definitely, there's information out there that you can use to learn AI. Data processing in Python is something that you should learn a little bit. There are many resources out there to do that. If you have any questions about where to find some, I can help you. So send me a note. You should know a few core AI algorithms for common business use cases. So the key thing to remember here is that AIs that can beat humans at chess, for example, are really cool to read about in the news, but most businesses are not looking to beat humans at chess. Most businesses are used to looking for basic things like, can I predict how much budget I need next month? Can I predict how to price my new product so it'll get, more sales? Can I figure out how to recommend other products? Can I find customers that are likely to leave me, and so that I can intervene before they decide to cancel their contracts? Can I find anomalies such that if I'm being hacked, can I find out? Can I detect fraud? These are the things that you want to understand the algorithms for. And even though there are hundreds of algorithms out there in the AI world, there are some really solid algorithms, under 10, that will just make you good at these kinds of things, because this is what most normal businesses do. Then the key thing that you really should do is also demonstrate that you can solve a real world problem with these skills. Now, you don't need private data to do that. You can find extremely good public data, in places like Kaggle or CDC or anywhere like that, which you can use to solve problems. And so, students that I've had experience with in the past, they learn these things, they find a problem they care about, they build an AI in the production to solve this problem, and then they present a report, and sometimes they write a public article, like a Medium article, describing what they built. This is a great indicator to a potential employer that you, first of all, appreciate that you have to solve a problem. You are able to go through all the steps of it so that they know that they can rely on you. And you're able to also report your results, because you will need to report them to a manager at some point. And so it gives, like when I, look at hiring people, I look for not just what technical things they know, but their ability to solve a problem, either by themselves or with a team. And a capstone project for a student who's looking to break into the field, it's a very good way to tell an employer like me that you know how to build things and you know how to solve problems. And so generally, if you have something like this, it's a good way for you to get started, and it'll give you a feel for the things you need to know. And then once you decide to specialize, you can then take a specialization course to focus on something that you really want to specialize in. And that will then, prepare you to basically take a job. So I think that's all I had. So we have about 18 minutes left. So should we take questions?
Yes, Nisha, we have quite a few questions for you today. I think let's just quickly open the floor to the audience.
Sure. Do you want to just read out questions to me, or how do you want to do this?
So Shraddha will invite the audience. She's going to unmute.
I'm from the Q&A window. I'm just going to start unmuting one by one.
Okay.
The first one we have is Chaitanya. Chaitanya, you're up.
Yes, I can see your question also, Chaitanya. Would you like me to just answer that, or did you want to? Sorry, I'm just trying to figure out what I'm doing here. I'm trying to click on the thing. Okay, so you would like me to read out your question?
Chaitanya, you need to unmute before you talk.
Oh, I'm sorry. Thank you so much for all this information. Yes, I'd love it if you could answer that question. And I also have another question. Basically, I have 6 years of experience in operations. I'm trying to use that to get into a business analytics role. I recently took a course in R programming and Power BI and a bit of machine learning.
Okay.
I'm wondering, when I apply for these roles, I also get asked for some Cosmos and other skills. So I don't know which ones to add on to start off in the beginning. What are the basic skills I need to have apart from R and Power BI and Excel and SQL?
Sure. So are you looking for like a business analyst role? And what are the questions that are being asked of you? Are they more about different BI tools, or are they more on data science kind of tools?
So I'm looking at more operations analyst and business analyst roles so that I can use my industry expertise and draw insights. Again, you can tell me if I'm looking at the right roles, but they mostly seem to be on drawing insights and, helping out the data scientists.
Okay, so one thing I would suggest is, if you haven't already studied, have you studied Tableau yet?
Not yet. Power BI, which
That's
is
good.
Pretty similar. So
Yeah.
Yes.
So Tableau is an extremely, popular infrastructure right now for this kind of BI. So, some experience with Tableau will definitely not hurt. Things like data science algorithms, that are embedded in BI techniques might not be bad for you to know something about them. R is, by the way, a good analytics language. So the way to think about R and Python is that the AI space is complete, it's always evolving, right? And there's a massive array of languages. And until about 2 years ago, R was the winner and Python was a little bit behind. Right now, Python is the winner and R is a little bit behind. And
Yes.
what happens is that people who came from the business side and people who came from the statistics world are R first. People who came from the engineering world are Python first. So given where you're at, I would say maybe learn a few more algorithms, try to pick up some Tableau, and try to see if you can demonstrate that you've built a project, right? Using some form of analytics. And one of the things right now, for example, is that it's very easy these days to publicly build projects and share them. So I encourage write Medium articles about what they do. And that way, it's like a little resume for you that you write on your own terms. So that's what I would recommend. Does that make sense, Chaitanya?
That makes a lot of sense. Thank you so much. So do you suggest that I'm looking for the right roles if I'm trying not to start at entry level because I already have so much expertise in my industry? So what are the kind of roles that I should be looking for?
So, I mean, that's really kind of your decision, right? I would think that if you don't want to do an entry-level role, I think you're doing the right thing. If you want to do more, so one thing you could do to kind of, hedge your bets is you can look for a role in the ops and supply chain that is not entry-level. At the same time, you can take some data science courses that then you're not accepting an entry-level position in data science, but you have the skills. And then within the company that you're in, you might be able to, negotiate for a more senior data scientist role right from the get-go.
Interesting. Okay. All
That's
right.
what I would do. I wouldn't necessarily give up what you have and, discount your expertise and then go in entry level.
Okay.
You just go into a company that has a data science department, learn some data science, get to know them, and see if you can enter them at something other than entry level. So maybe take a job in your field, but don't take a job in take a job in a bigger company where a lateral move is more possible.
Okay. All right. Great. Thank you so much. This helps so much.
No problem. Okay. Who's the next question? So yeah, who's the next question?
We have Vaishali. One second. Vaishali, yes, you're up.
Hi, Nisha. Thank you for this session. This was a very informative session for me. So a brief background about me is that I have been an SAP BI developer for 12 years, where I've done the interaction with the business users and developed the objects and the business reports that the business users use for analysis. So what do you think is the best fit for me? Because I have been out of the career for a few years and I'm looking to get back to workforce. So looking at this, what do you think is the best fit for me in the data science world?
So, you've done programming. When you were doing programming, was it more kind of on a client side, or were you doing more production systems programming? And what languages were you in?
So basically, I was into SAP, and SAP has its own language, SAP ABAP, which is more of a SQL-based programming language. But recently I've been trying to update myself with the Python programming and a little bit into the Tableau too. I haven't completed the course, but I'm still doing those courses parallelly. So
makes sense.
what is your suggestion?
I would suggest the data science function, because what you're doing, particularly the fact that you're learning Python, I think data science would be probably better fit for you. ML engineer roles tend to be quite far removed from the kind of SAP programming that you've done, but the data science would be a nice, segue for you. So that's what I would suggest. It's good that you're learning Python. I would suggest, that you continue to learn Python and then learn data science. You can also, by the way, learn data science in the context of SAP. It's not as useful a skill. It might be a little easier for you to get started, but if you are going to do data science, I suggest you bite the bullet and just take on Python from day one. It'll just serve you so much better.
Okay, great. Yeah. Thank you so much, Nisha.
Not a problem. Next question.
Yes, the next question is from Mamta Kumar. Mamta, can you please unmute before you post your question?
Hi, Nisha. Can you hear me?
Yes, I can hear you, Mamta.
Yeah, thank you so much for presentation. I haven't started anything in data analytics, but I just was wondering what skills are required. So you gave a very nice presentation. Just one question, that is the presentation skills are very required to succeed in this role, especially in data analytics? Like, I heard that you have to like pursue and I mean just convince people what you found or not. And then my second question is that after doing all the courses, and if I don't have any experiences in data analytics, then how I'm going to find a job? Because at least they need 2-3 years of experience, right?
So I think you have several questions there, and let me answer them one by one. Presentation skills tend to be very important, and for exactly the reason you mentioned. Right? Data science is an emerging field, and say that, for example, you created a model. You're part of a team. It's important that you develop the skills to not just create it, but also explain people why it's important. So the presentation skills are really a very important part of being a data scientist, and less so in a machine learning engineer. For data scientists, it's very important. Now, whether or not you need experience, remember, everybody starts somewhere, right? So anybody who has 2 years of experience at some point got a job with none, because that's how they got their 2 years of experience. So the reason the capstone projects are so important is that they demonstrate what you can do before you, get an actual job, and they also demonstrate your ability to present what you can do. So what I typically advise students who don't have a job, who are to demonstrate their ability to build using a capstone. Take the capstone seriously, go through every stage, build an AI that works, write about it, describe why it worked and what you did. And I have personally hired students who don't have experience, and I hired them based on the strength of what they've shown me in their projects. And it's a trade-off. And so what you need to do is to find a job where, really the key thing to keep in mind right now is that there are so few people to hire, and the people who have a lot of skills are so high in demand that sometimes it's just too expensive to hire them. So what you need is to find an employer for whom this is a win-win, where they're basically taking you on knowing that they'll have to teach you some things, but you are in turn showing that you're smart, you're capable of building real problems, you've shown your capstone, and then it can become a win for both. And I have hired people like that, by the way. So that's what I would encourage. But without the capstone, it can be really hard to tell what you're good at.
Okay, thank you.
Yeah. So I think we have about 8 minutes left, Deepika and Shraddha, so we can probably take a few more questions.
Yes.
Oh, sure. So the next one I have is Vani.
Hi, Nisha. Thank you for
Hello.
the very informational, all the information that you provided. For me, it was an eye-opener because I've always wondered what data scientists and analysts do.
Okay.
And I keep hearing a lot from a lot of my family members as well. So it was very informational. But one thing that I keep wondering is all the clients and everybody would be sharing a lot of real-time data, right? So how does it work with the data privacy, and what exactly do people look for, especially when it comes to data privacy? How do people take care of it?
No, this is an extremely important question, and I'm glad you raised it. So what's happening right now is that there are a lot of emerging regulations in the data science space, and some of them concern privacy, and some of them concern other aspects like fairness and trust. So there, for example, about a year ago, Europe launched a regulation called the General Data Protection Regulation. California this year launched the California Consumer Privacy or Consumer Protection Act. And there are local and state laws in different countries, and and things like that. And there, some of them are vertical oriented, like finance, for example. The United States Security and Exchange Commission has laws about this, and healthcare has a whole set of laws of its own. So what typically happens is that the companies in question, they have a set of laws that they need to abide by, given where they do business and what industry they do business in. Those laws then in general filter down into specific things that data scientists are allowed to or not allowed to do. One perfect example will be that if you're in a company like a bank, okay, and a bank where you are in the data scientist team in the bank, you will find that you can't just get access to any data you like. You have to go through an approval process. And then you have to keep very clear track of exactly what you did with the data. And if you come up with a model, for example, chances are no one will use that model until you explain exactly what data you used, and they validate and make sure that the company has not broken any laws by using that data for an AI. So from a hiring perspective, what I tend to look for is I don't necessarily expect data scientists to know the exact laws of my industry, because it's my job to teach them that and make sure that they, comply with the laws. But the fact that you appreciate that there are laws, and the fact that you know that you can't just go around, grabbing anything you like, right, is usually the first clue to a hiring manager that you're a safer hire. So this is really important, because you wouldn't believe the amount of hiring managers that lose their sleep over this. In fact, I once talked to a bank VP and he's like, I had to send an email to my entire data science team saying, do not build any AIs without checking with me first. Like, this was utterly ridiculous, and but he was like, I had nothing else to do because they kept running amok, right? And building stuff. So I would say, all I usually look for is awareness. And this is part of being a good team member and understanding what your business cares about, right? And as long as you play that, usually industries know what rules. They spend a lot of time figuring out what rules they need to comply with. Your manager will tell you, and then just follow them. Okay.
Gotcha.
Great question, though.
Thank you.
You're welcome. Okay, so I think we have about 4 minutes left, and I do need to take a hard stop at 11. So maybe 1 or 2 more questions.
Okay, sure. I'm just going to take Sudha Kannan. Sudha, please unmute before you post your question.
Hi. Again, a little bit background about myself. I've been a programmer, but I've been out of work due to taking a break for personal reasons. I'm trying to get back into the field, and data engineering seems very, very lucrative and quite in sync with what I used to do before. So I've been taking up these MOOCs, especially I took up a data engineering on a GCP platform course, and I'm still doing that right now. But unfortunately, it doesn't have an end capstone. But I'm hoping that at the end of it, I will be able to build my own. And does having AWS or GCP add any value to your data engineering when you look out for careers in them?
So generally speaking, yes, it does add value. They're some of the best known tools out there. Because you're a programmer at heart, I suggest that you look at more of the ML engineer kind of approach, because it also depends on how much you want to get into math, right? And so I'm, for example, more on the ML engineer side. I like the algorithm, and I love math. I just don't have time to do a lot of math. So I would suggest you do that, because it sounds like you enjoy programming. You've done it before, so it's a good thing. The cloud tools are good, and the good news about the cloud tools is that if you learn 1 or 2 of them, generally the other ones are not that hard to learn. So, but I would strongly suggest you build a capstone, yes, because the capstone is really the most important thing.
Okay. The course that I've enrolled in doesn't have one, but I'm hoping that by the end of it, I should be able to build one. But there's also a lot of courses out there that use a lot of Apache tools. So is it something good to have in your skill set, like Apache Beam, Kafka, and also HDFS and Hadoop? How important are these to know?
Good point. So a couple of things. So in the land of tools, none of the tools that you mentioned are the ones that I would right now invest in learning. Because Kafka, by the way, is a wonderful tool, but Kafka is usually for streaming, and the vast majority of AI use cases right now are not streaming, they're batch. So I would consider Kafka to be the kind of tool you learn after you learn some batch tools. So, and Beam is basically a multi-federated streaming tool coming from Google that Google put into Apache. And again, Kafka is less used than batch, and Beam is less used than Kafka. So it's not a good place to start. Hadoop is still very heavily used, but Hadoop has largely now been supplanted in favor of in-memory tools like Spark or TensorFlow. So for a level of investment at this point, I would say learn some cloud tools or learn Spark or learn TensorFlow. Those will serve you much better right now. Or anything Python, like Kubernetes, Kubeflow, Dask, Flask. All of those are definitely much more useful than learning Hadoop.
Okay. Yeah, thanks for that.
No problem. So I'm going to need to drop off, guys. Maybe what we could do is thank you so much. I really appreciate, being able to talk to you. So I can follow up with you. And if there are some questions that, you want to send me over email, I'm happy to try to answer as many of them as I can.
Yeah, Nisha, thank you so much for the deep dive into the data science topic today. This session was really informative. We now know what kind of roles there are in this space and what it takes to launch a career in this space. So we will be sending an email post the webinar to all the attendees today with today's presentation, and also information about you and your organization and the training programs that you offer in this particular space. So they will be able to reach out to you directly.
Awesome.
Thank you so much for your time.
Thank you, guys. Bye-bye.
Thank you, Nisha. Thank you, everyone.